Welcome again to another one of my mathematics sessions. In this tutorial, we will be looking at addition, subtraction, and multiplication of vectors. If you haven't seen my previous videos on the triangle law and parallelogram law for vector addition, please be sure to do so. Here on the screen, you are seeing a demonstration of what the triangle law entails as well as the parallelogram law. Our triangle law states that it is easy to perform addition on two vectors if they are connected from head to tail. For example, I have three vectors here, AB, BC, and AC. If I perform addition on AB and BC, I am noting that my head of the vector AB is connected to the tail of the vector BC. Now, when I perform addition on AB and BC, my result is the vector AC, and therefore the vector AC is called my resultant vector. My parallelogram law shows that I can perform addition on two vectors even though they are not connected using my head-to-tail format. I can see here that addition was performed on the vectors AB and AD, although they are connected using their tails. They have both originated from that single point, and it is saying that if I add the vector AB and AD, my resultant vector is that vector that is formed from the diagonal of AB and AD. Now, as I said, if you haven't looked at my parallelogram law video, please be sure to do so. Now, let's take a look at what the triangle law for addition looks like on a Cartesian plane. So here we have a triangle that is formed from three vectors, PQ, QR, and PR. Now, we can see that PR is the resultant vector that is formed from adding PQ and QR. So I'm going to write here PQ plus QR is equal to PR. Now, we are going to learn how to go about performing addition on vectors using the column vector format rather than the directed line segment format. So, I'm going to determine what the vector PQ is. Remember, to get from P to Q, a movement is traveled along our x-axis followed by our y-axis. So that movement along our x-axis from P was in the right direction. So I went in the right direction to get to Q. So I went from -6 on my x-axis all the way to -4 on my x-axis. So I made a movement of +2 on my x-axis. So to write the vector PQ, it's going to be 2 at the top, and then I had to move upwards 2 units, and in an upwards direction is +2. So to get from P to Q, I went 2 units to the right and then 2 units upwards. That is what this vector here is telling me. Let's look at the vector QR now. How did I get from Q to R? To get from Q to R, I am going to have to travel 2 units in the right direction, which is along my x-axis, and then 2 units downwards in my y-axis. So 2 units to the right on your x-axis is represented by positive 2, and 2 units downwards in your y-axis is represented by negative 2. This gave us the resultant vector PR. How did I get from P to R? I would have to move 1, 2, 3, 4 spaces to the right, and I am not going to move either up or down on my y-axis. So that is represented using the vector 4, 0. Now let's examine this. Notice that the vector PQ is 2, 2, and the vector QR is 2, negative 2. And when I performed addition, I got the vector 4, 0, and we can see that this was obtained by simply adding our movements along our x-axis together to get 4, and adding our movements along our y-axis to get 0. So 2 plus 2 gave us 4, and 2 plus negative 2 gave us 0. And that there is one method that can be used to perform addition on vectors. This is called addition of vectors using the column vector method. Now let us have a look at subtraction. In order to subtract vectors, we add the inverse of the vector. Now what is the inverse of a vector? If I have the vector BC, the inverse of BC is going to be CB. If I have AC, the inverse of the vector AC is going to be CA. Remember, the inverse of a vector is simply a vector in the opposite direction. So how do we go about subtracting BC from AC? This is the same as saying AC plus the inverse of the vector BC, which is CB. This is going to give us the vector AB. How I know it's going to give us the vector AB? Because we started at A and we ended at B. That is how we determine what our resultant vector is going to be. Now, when we have a vector written in column vector form, for example, let's say the vector 2, negative 3 is the column vector form of the vector AC. To write the inverse of the vector AC, it's CA, and CA can be written as negative 2, 3. So it's simply to change the signs of our numbers. If it was positive, it's going to be negative. If it's negative, it's going to be positive. So if the vector AC is 2, negative 3, in order to derive the inverse vector CA, I simply change the signs of those values there. Now let us look at multiplication of a vector by a scalar quantity. So let's consider these vectors here. Let's look at the vector PQ. If the vector PQ is multiplied by a positive scalar quantity, it is going to go in the same direction as PQ. For example, I have multiplied PQ by 2. 2 is a scalar quantity and it's positive. So because it's multiplied by a positive scalar quantity, it was drawn in the same direction as PQ. And because it's 2, it was drawn twice the length of PQ. If it was multiplied by 3, it would have been drawn 3 times the length of PQ in the same direction. If, however, PQ was multiplied by a negative quantity, the direction would have been in the opposite direction. For example, PQ was multiplied by -1 here. So I drew the vector PQ in the opposite direction of PQ. Notice it was -1, so it remained the same length, but in the opposite direction. PQ here was multiplied by a positive scalar quantity, although it was a fraction. This fraction is +1/2, so we drew the vector in the same direction, but half the length of PQ. Here, PQ was multiplied by -2, and because that scalar quantity is negative, it was drawn in the opposite direction, but twice the length. Now, let's have a look at what multiplication looks like when it is given in the column vector format. Let's say PQ was given as 5, -3. Remember, 5, -3 means 5 units along your x-axis in the right direction, and -3 means 3 units downwards on your y-axis. Now, if PQ was multiplied by 2 to get 2PQ, it would simply mean that I have to multiply 2 by each one of these values here. I would have gotten 2 by 5, 10, and 2 by -3, -6. And that's how you perform multiplication when given in the column vector format. Now, let's have a look at one more scalar multiplication in the vector format to end this video. So let's say we have the vector AB, which is 4, -6, and we want to find half AB. Let's make it a negative scalar quantity. So it's -1/2 AB. What I need to do is multiply that -1/2 by each one of my values in here. So it's going to be -1/2 multiplied by 4 and -1/2 multiplied by -6. And I am going to get -2 and +3. -1/2 by 4 gives -2, and negative by negative is positive. 1/2 of 6 is 3. And there you have it, addition, subtraction, and multiplication of vectors.
Don't forget to like, share, and subscribe for more of my videos.